Hi, in this video, we're going to look at elastic collisions and how momentum is conserved in elastic collisions. So let's get started. In a made-up game on a billiard ball table, Logan rolls a 7 ball at a speed of 5.6 meters per second toward the center of the table. On the other end of the table, Harper rolls an 8 ball at a speed of 3.4 meters per second toward the center of the table. Both balls have a mass of 0.55 kilograms. They collide elastically with each other. That is, they bounce with no loss of momentum, and they bounce back in the opposite direction that they originally traveled. The 7 ball moved back with a speed of 2.3 meters per second. What is the velocity of the 8 ball after the collision? So in this example, we have two balls that are headed toward each other. They bounce, and then they bounce back away from each other. So to draw a picture of this, I started by drawing a 7 ball and an 8 ball. And I showed that the two balls were running toward each other. And then I drew them going away from each other for my after picture. So you could also label these velocity vectors with the amounts. I'm not going to worry about that right now, but it's a helpful strategy to go ahead and label, like, the 7 ball is moving to the right at 5.6 meters per second. And you can write that out beforehand, and it sometimes makes things a little bit easier. But what we know about elastic collisions and isolated systems where there are no other forces acting on these two balls, we know that the momentum between the two of them is conserved. You have the total starting momentum, then that total starting momentum doesn't get lost, it's conserved, and so it is equal to the total final momentum of the system. The system here is the 7 and 8 ball together. So to find the total initial momentum and the total final momentum, we simply need to add up the mass times velocity of each ball before and after they collide. So mv all around. I'm going to label this mass of the 7 ball, so m7, times the velocity of the 7 ball. But I need to specify it's the velocity of the 7 ball before the collision, not after the collision. So I'm going to write 7i to be initial velocity. So that's the initial momentum of the 7 ball. Then I'm going to add that to the initial momentum of the 8 ball. So that's mv, and I'm going to write 8i for the initial velocity. I don't write an I for the mass because the mass of the ball doesn't change. And so that's going to equal m7 v7 final, the final velocity times the mass of the 7 ball, plus the 8 ball's mass times final velocity. So again, there's a lot of subscripts here, and it's important to be precise and clear with our math symbols so that we don't get lost or we make mistakes that way. So now that we have all of this worked out, we can start substituting in some numbers here. And we're going to have a lot of numbers to write. The mass of the 7 ball and the 8 ball are the same. They are 0.55 kilograms. The initial velocity of the 7 ball is 5.6 meters per second. The initial velocity of the 8 ball is 3.4 meters per second. Okay, but I'm going to pause here because I need to say one of them is in the opposite direction. This is the most easy mistake that you can make when you're doing these kind of problems. You need to specify which one is moving in the positive direction, which one is moving in the negative direction. The way that I've drawn my picture here, the 8 ball is moving to the left, and so I'm going to put a negative sign in front of this 3.4 meters per second to say that it's moving to the left. All right, now I can continue. We are told that the velocity of the 7 ball is bouncing backwards at 2.3 meters per second. Now look again at my picture. We need to check this really every time we write down a velocity. What direction is the 7 ball moving after the collision? Clearly in the picture, it's moving to the left. And so we have to take that information of what we know the balls should be doing, and we have to translate that into positive and negative signs in our setup of the equation. It's essential that you keep track of the direction of the balls before and after, because it will change our outcomes when we're doing these kinds of problems. Momentum is a vector, and so you have to pay attention to the direction. That's the whole point of a vector quantity. So we have to write negative 2.3 meters per second for the 7 ball. All right, then we don't know the velocity of the 8 ball at the end. That's what we're going to be solving for. So now that we've got all our numbers here, we can just do some algebra, and I'll try to make this quick. So using my calculator, I'm going to do 0.55 times 5.6 is 3.08. I'll round that to 3.1 kilograms times meters per second. And then we're going to have a negative answer over here, minus 0.55 times 3.4. So that's a negative 1.87. I'm going to round that to negative 1.9. I'm rounding to only have two decimal places here, or two digits, because our original numbers only had two. So we can't be any more precise than just keeping with the two digits. So 0.55 times negative 2.3, I'm going to round that to negative 1.3 kilograms times meters per second for the 7 ball going backwards, and mass times velocity of the 8 ball at the end. All right, so now it's just a simple matter of adding and subtracting. So I'm going to start on the left here, 3.1 minus 1.9. It gives me 1.2 kilograms times meters per second. And that's equal to negative 1.3 plus 0.55 times the velocity. Okay, now that we have this negative sign, remember to undo a negative, we're going to add 1.3 on both sides here. 1.3 kilograms times meters per second. So add that to both sides. And again, this is why you have to keep track of that direction, because if you don't have the negative sign there, this is going to be a completely different answer. So 1.3 plus 1.2 is 2.5 kilograms times meters per second. And that is equal to 0.55 kilograms times the velocity of the 8 ball at the end. Now we're ready to undo this division here, or undo this multiplication by dividing. The kilograms cancel out, these numbers cancel out, and we have 2.5 divided by 0.55. It gives us 4.5. So the velocity of the ball, the 8 ball at the end, is 4.5 meters per second. It is a positive answer, so it's to the right. And we should check and make sure that that makes sense, that this is a positive velocity for the 8 ball. If we look back at our picture, yes, the 8 ball is moving to the right, which is the positive direction. So that would make sense for this particular problem. So that's all I've got for you in this video. Remember, how you do anything is how you do everything.